All right, so really important lesson because we're talking about titration and we're talking about the techniques to do this and also accuracy improving things as well. If you're aiming for an excellence on this internal, not only do you need to practice this technique when you're doing the experiment, but also you're going to be justifying your method that you create and also justifying your results. And in order to do that justification, you need to talk about accuracy improving techniques that you've done. So to start off with, I had you guys just play with the indicator, which was pheno. And what you guys would have noticed that if you had it in an acidic solution, it was colorless. And if you had it in a basic solution, it turns pink. And so that's what we're going to use as our indicators for this titration. I don't know if you guys noticed, but I gave you guys two different concentrations on purpose. The acid was at 1 mole per liter, and the sodium hydroxide was at 2 moles per liter. And what I was hoping you guys were going to realize was that you needed to add quite a bit of acid to make it go back to colorless. And that's because this sodium hydroxide was way more concentrated. In fact, you just needed to add a little bit of this to get to that pink color. So I thought that was just a good way for us to kind of think about titration and why we're doing it. Some of you guys noticed that when you added the acid back after having it pink, there was some white cloudiness. That shouldn't have happened. I'm not sure what in our chemicals was doing that. It's probably something's old, but you shouldn't see any white precipitates forming in any of your titrations. Are we good so far? This is really hard to see. All right, cool. So let me walk you through then what we are doing with titration. So we have two solutions that we are going to give you guys. The first solution is going to be our base. This base here is sodium hydroxide. I don't know if you can see it on the video. There we go. And with this solution, I know its concentration. It's at 1 mole per liter. So when we're doing titration, there's always going to be one that we know the concentration for and one we don't know the concentration for. So that's my first solution. The second solution that I have is, in this case, the bottle is labeled undiluted purified household sour cream. So I'll just hold that to the video so hopefully you guys can see it. So this is my unknown concentration, and by knowing the concentration of this one, I can solve for the concentration of my unknown using the titration process. Trying to think what else I want to add about that so far. The whole purpose of this assessment is to figure out the quantity in a household substance. So in this case, our household substance for this example is sour cream. It's been purified to remove all the other whatnots in there, so that way we can just measure the lactic acid, which is in here. So that's kind of an overview of what's going on. So that answers the first question of what two solutions we are using. We'll always use an acid and a base because we're doing neutralization. All right, the chemical that's going inside my burette is going to be the basic solution. Brooklyn, question? So a base is, what is the base? Sodium hydroxide. And in this case, the concentration is 0.1 molar.
Unknown.
The unknown is undiluted purified household sour cream. Purified household sour cream. And what you're measuring in this is the lactic acid. All right. Keep going. Sorry, this keeps fogging up. I'm trying to balance between the fogging. All right. So second question there is what chemical is going into the burette. In this case, what's going into the burette is my base. Make sure you are reading the method because each method will be slightly different. In this case, the method is instructing me to put the base inside the burette. Most often, you guys are putting base inside the burette. I think B and B. All right, the second one is what's going into the pipette and then being allocated inside the flask. So what's going into the pipette is going to be our sour cream liquid, aka our acid.
Sorry, what was the acid again?
The acid is lactic acid.
Lactic.
Lactic. The same acid that builds up in your muscles when you're exercising.
Oh.
Lactic.
Same one that you throw up?
Actually, acid? I think it's hydrochloric, what our body makes. All right, can I keep going?
Yeah.
Okay.
Maybe.
So this is what's going to go into my pipette, and then with the pipette we aliquot that into the flask. So these things will have my acid in there. Are we okay so far?
Wait, the acid is sour cream?
The acid is purified sour cream.
Purified sour cream.
So I purified it, so I just have lactic acid in here, because that's all I want to measure.
Oh, so you purified sour cream.
Yes.
Oh my god.
All right, can I keep going?
Yes, you can.
Okay. So, before we do anything, actually let me first kind of work with labels. So one of the things that you need to do, let me grab a whiteboard marker. Happy if you guys do this with permanent marker, you just gotta make sure you clean it. Is that we want to label our beakers because all of those solutions are colorless. And so it's very easy for me to mix them up. So you're going to have 3 beakers when you guys do your practical. One I'm putting a nice big A on for my acid. One I'll put a B on for my base. And then the third beaker, I'm going to put a W as my waste beaker. Are you okay so far? I'm doing that right now. Okay. So, acid base. So, as I was saying, my acid is going to be the sour cream. So I'm going to pour that into my beaker. We don't need a whole lot. I'd rather you guys pour less than more so that we can come back and get seconds. In my base beaker is going my sodium hydroxide. Are we good so far with that? So the reason why you do this is because that way you can leave the containers at the front for other students and you walk away with your 2 beakers. All right, step number 4 is that before we start any titration, I need to rinse my equipment with what is going inside it. So with the burette, I would rinse with the base, and with the pipette, I would be rinsing with the acid. Are you okay so far? Now, the reason why we need to do this is because of 2 reasons. First reason is I don't know who used it before me, and I don't know if they have taken proper care of the equipment. I don't know if they've cleaned it properly. So one reason why I do this is that it's a cleaning technique. Now I want to clean with what I'm putting inside the burette and putting inside the pipette because I don't want to use water. Any ideas to why I won't want to use water? Not block, but you're right. I want to use distilled water. So everything has been made with distilled water because I don't want to have any of those ions in there because that can crystallize and ruin my equipment. But why wouldn't I want to rinse with distilled water?
It doesn't have any of the ions or whatever.
Well, it's because I don't want to accidentally dilute either of my solutions. Oh, does that make sense? I don't want to accidentally dilute any of my solutions. So if I use water to rinse my pipette and to rinse my burette, there's going to be little water droplets left over in my burette and in my pipette as well, and that's going to influence concentration. So we want to rinse to make sure everything's clean, but we also want to make sure we rinse with whatever we're putting in there. So with the burette, I'm going to rinse with the base. You guys do not need to fill the whole burette to rinse it. You just need to give a little bit in there, okay? Because I don't want you to go through buckets and buckets of solution. So here's my base. Base is going inside the burette. I just chuck a little bit in there. It's not even maybe 10 mils. I have it closed so that way I can open it and flush it out. So that's how I'm prepping it. And it's going to take a little while, which is fine. So that is rinsing of my burette. The other thing I want to rinse is my pipette. Now this pipette actually is probably a good idea I rinse it because it looks like it's got a lot of dust in there. So I'm using a 10 mil pipette, and when you rinse your pipette, I fill over the line. And the reason why I want to fill over the line is because just in case you overfill, you want to make sure that area is also clean as well. So since the acid's going in my pipette, I'm going to rinse that out. I personally like these little squeegee ones. You guys will find which one you like. But I'm just trying to overfill it. Make sure I really get a good amount in there. And again, this is waste, so it's going into my waste beaker. So this one I do want you to fill all the way to rinse it out. Okay? And that's all prepped. So that's step number 4 that we're looking at. I rinse all my equipment with whatever I'm planning to put inside it, just to make sure that it's clean, because I don't know who's the little dork that used it before me. And also to make sure I don't accidentally dilute it. Cool. All right. So now I can start putting things where I want to put them. So base is going inside the burette. So now I can fill this out properly. Make sure the valve is closed before you do it. You don't need to get exactly on 0, but you should fill it up a decent amount. Just gonna let it sit up for a little bit. All right. And then the other thing I want to do is take my acid, take my pipette, take my flask, and what I'm going to do is I'm going to pipette 10 milliliters into my flask. This is known as the aliquot, is what comes out of my pipette. So again, you find what you like. Personally, I like the little squeegee ones because I like the control that you get with just using your thumb as the pressure point. You guys will have hopefully had a little play with them. I'm overfilling it so that way I have enough time to grab it with my thumb. And then remember, you want to go to eye level, and we're going to that line. So the bottom of the meniscus should be at the line. Make sure you take a paper towel just to dry any potential stuff that's on the outside, and then shift it inside to the flask. And you guys talked about this the other day. Some of the accuracy improving techniques with this is making sure you touch your tip of the pipette against the flask, so that way it sucks the last bit of it out. But you shouldn't be doing any blowing out. Okay? Are we good so far? That's okay, I don't need that right now. We good? All right. So when I look at step number 5, before I start titrating, I want to add my pheno into my flask, because that's my indicator. If you forget this step, what you're going to realize is that you're going to go through buckets and buckets of solution and nothing's going to happen because you can't see it because there's no indicator in there. It's pretty obvious when you've messed up. All right, so make sure you have the indicator in there. Cool. Are we all right so far?
Yes.
Okay. So let's talk about some of the accuracy improving techniques. So we've already talked about some of the ones that we use for the for the pipette, which is making sure we look at the bottom of the meniscus, get to eye level, make sure that you touch it against the flask. All of these things will help to make sure you get an accurate reading for the volume. Are we okay so far? All right. So now let's talk about the titration itself. One of the first things I'm going to do to help me improve my techniques is I'm going to put a white piece of paper underneath my flask. And the reason why I'm doing that is so that way it helps me see that pink color. I want it to be a pale pink because that means I'm as close as possible to that end point. And then my acid and my base should be equal amounts. If it gets too pink, then I've overshot. And in fact, you can see that in the slide notes that you have getting close. You should slow down or an overshot. So you'll know, and this is what you're going to have to practice with time, is getting to that right pink color. Are you okay with that one? Right. We see with B for step 6 is that we need to remove the funnel. So I want to remove the funnel because you guys can't see it, but I can see it. This funnel has some droplets of base in there, and that's going to influence the volume reading on the burette. So if I leave this funnel in here and I read the burette and then some drops fall in, it's going to affect the reading of that volume. So I make sure I remove this. that you guys need to remember. Any questions so far? All right. The next thing is we need to learn how to read the burette. And so important things about reading the burette. I have a step stool. First thing, just like with the pipette, I want to get to eye level to see the meniscus. So that's why I'm using my little step stool. Feel free to use step stools, use chairs to help you read the burette. I want to get to eye level with the meniscus because I don't want to introduce parallelix error. Have you guys heard of parallelix error before? In some of your other classes? I see head shaking, no, that's okay. So parallelix error is, you know how when you read a scale, if you read it looking down, it's going to read as a different number than when you read it looking up versus when you get to eye level. So if I get to eye level with my meniscus, I can then eliminate that error. So I don't want parallelix error, is basically what we're looking at. Another trick to help you make sure you read your burette properly is grab a white piece of paper and put it behind the burette, so that way you can read the scale a lot easier, because this is all colorless solutions, it's really hard to read it. So, putting my goggles back on, putting this in front, we're reading at the bottom of the meniscus, and I in fact don't probably have it exactly at 0, I have it at 0.10. So, I need to record the initial value that I see in that burette, and I'm writing 0.10 milliliters because we're going to measure the difference. Make sure you're writing your values to 2 decimal places because you can state if the meniscus is on the line or between 2 lines. If it's on the line, you end in a 0. If it's between the 2 lines, then you end in a 5. Are you okay so far with that? All right. So, when you guys do the titration, you're going to do at least 4 titrations. The first one is known as your rough titration, which is just to give you a ballpark figure of how much base you need for that acid neutralization. So it's okay if it's not a good number. It doesn't have to be super accurate. It's just to give you an idea. Once you know that ballpark, the next 3 titrations need to be accurate. And I'm happy if you guys want to do extra titrations and maybe do a 5th one if you notice that your data is not concordant, so they're not within a range of 0.3 of each other. Are okay so far? All right, so I'm going to go ahead and start doing that titration. So I'm going to open up my valve, and I'm keeping an eye on my flask to see if it's changing color. I'll hold this up a little bit higher so hopefully you guys can then see it. What I'm hoping to get is a pink color. It's useful if you swirl the flask so that way it mixes well. But we can tell so far I'm like 10 mils in and there's no color change. And that's why the first titration we do is the rough titration, because we want to get a ballpark figure. I don't want to be slowly dripping at this point. So it's going to take a while. I know it's going to take a while because I know what the ratios are. And again, that white piece of paper will help you see if there's a pink. Currently, looking at it, there's no like faint pink that's starting to form. So I'm going to keep letting it go. Now we're going to realize a problem eventually, and that's I'm going to run out of solution, which I did on purpose, so don't worry. Any questions so far? For number 8, so my rough titration is just your first titration. It's just to give you a guesstimation about the volume of base you need. So that's why you see how I'm not doing this very accurately. I'm just shooting the solution straight into my flask. That is rough. And that's okay, because you're not going to use this as a data point. You can use it as a data point if it's concordant, but you're probably going to exclude it. Do you guys know what concordant means? The rough titration. So it's just for me to get a ballpark like an estimation of the volume of base I need, or the volume of whatever is coming out of the titrate, and the titrate is referring to what's coming out of the burette. So I'm getting close to using 50 milliliters, and I still don't even see any pink going on. I haven't actually made a mistake, it's just I'm trying to prove a point about why we do part A. Alright, so what I'm going to do is I'm going to stop it at 50, and I'm going to refill my burette, which is not what you want to do during the assessment. Okay, stop it there. I'm going to refill it. Okay, so, we were talking about concordant. So concordant values just means that your data set is nice and neat and close together. We don't want a huge range, because if we have a huge range, that means you have a lot of potential accuracy issues. So for this assessment, if you want merit or excellence, your values need to be, from memory, 0.3 of each other. So 0.3 milliliters. If it's not concordant, do another titration, and then from there, see which one to eliminate as an outlier. You guys have talked about outliers in biology. Alright, so I'm going to put some more base in here. So I have a problem, because I had to refill it, which is not what you want to do during the assessment, and I actually need even more base. And the reason why I'm doing this is to show you guys what a bad titration looks like. So you don't do this. So I don't want you to refill the burette. If you're refilling the burette, you've done something wrong. So I'm going to make a note that I've refilled it. So basically I've used 50 milliliters. I'm going to remove the funnel before I do any readings. That one's just a little bit over 0. So I'm going to reuse my base and just get rid of some of that excess. And that should hopefully put me back at 0. Alright, once again I'm going to keep going and adding base into my flask. And once again I'm going to try to get this pink color. Now I purposely made a mistake so you guys can see the importance of what part A is for. Alright, I can start seeing some pink forming, but it's not holding, it's disappearing very quickly, so I know I still need more. But once I start getting close to that pink, I can switch my technique. And again, that swirling helps make sure it's all mixed. And in fact, I might need to refill this 3 times because there's quite a bit of acid to base. I'm just going to leave that because I know it's going to be a while. And I might need to refill it a 3rd time, which is not ideal, but a good way to teach you not what to do. And I can see with the flask that there's a slight pink that's forming where the base enters, which tells me I'm getting closer to that point, but I'm still quite a way away from it because that pink color isn't staying. So I might need to refill this for a 3rd time. But again, like I said, it's to prove a point. Alright, any questions that you guys need me to go over again? Keep an eye on what you're doing, because you don't want to accidentally... I mean, it's the rough titration, so it's okay if we're too far. I just need to get an idea of what's going on. And I'm just watching it because I'm going to stop it at 50 and refill it again. And like I said, I did this on purpose. I didn't... Alright, cool. That's 50. Filling it again. So I'm making a note that I refilled it twice. Hopefully this time it'll be enough. And knowing my history of how long this has taken, I'm actually going to fill it. So I'm still in my first titration because I actually haven't gotten it to turn pink. All right, remove the funnel. Check, it's a little bit high. So I'm getting rid of some of that base. Put that back underneath it. Pull right down the measurement. All right, I'm gonna try to get this to turn pink. Like I said, it's needing buckets. Hopefully it actually does turn pink. I'm gonna get my ratios like completely mucked up. Oh, there you go. So we're starting to get that pink to stay a little bit longer. Hi.
Could I grab a few students for the dental checkup?
Yeah, go for it.
Okay,
Oh, there we go. Not starting to turn pink. Oh, yeah. Sorry. Big titration.
It's pink.
All right. Klein, Zara, Ruben. Thank you. For the dentist.
Take it just in case.
All right. So you see how it's starting to turn pink, but the pink isn't staying. So I still need more. There we go. That's probably it. All right. Do you see that? Oh, it's not really staying. I might need a little bit more. So that's the titration. We're starting to try to get it to pink. It didn't hold the pink color, so what that tells me is that I probably need a little bit more base. Now, it's only my rough titration, so I'm not trying to accurately do it. But if I was trying to accurately do it, what I would do, if I was at this point, is I would switch my titration, switch my burette, so that way it was dripping instead of full kind of valve pull. Or the other option is you just shoot a little bit in at a time. Alright, there we go. So, pale pink color that we're looking for. It's probably a little bit too pink for my liking, but it's a rough titration, so it doesn't need to be super, super accurate. Now that I've gotten it to that pink color, I will take my piece of paper and I will read to see what the value is, and it's roughly 25.40. But the problem is, alright, keep going. So I've read the burette and it's 25.4 milliliters as my final reading, but part of the problem is that I had to refill this thing twice. So I need to also factor in that there's 100 mils on top of the difference from this one as well. So that's why we record our initial and our final value. So if I was to do a subtraction from what I started with, the 25.4 minus the 0.1 puts me at 25.3 milliliters. I used 2 full burettes worth, so that's another 100. So it was 125.3 milliliters of the base in order to neutralize just 10 mils of the acid. That's crazy, huh? So it's basically 10 times as much that I needed to neutralize it. So some things to kind of note, and this is what number 10 is talking about. So one of the problems with this titration is that I had to refill the burette, and that's a big, big problem. And the reason why that's a big problem is for multiple reasons. The first thing is that I had to make sure I stopped at 50. So I didn't want to go below 50 because it's no longer marked. The other issue that I introduce is refilling it. So every time I refill it, I then have a new starting point, and I have to factor that in when I'm doing that calculation. So I said there was roughly 100 mils that was used because of the 2 refills, but I'm not 100% sure if that was accurate. And then, like I said, every time we read it, we can potentially introduce errors. So the thing you need to keep in mind is that we don't want to do this. We don't want to refill our burette. If you're refilling your burette at any point during the titration process, start over, because that's wrong. You're going to have really bad data from that. The other reason why you don't want to do this is because you're going to use buckets and buckets and buckets of solution. So you saw there that I had to refill this multiple times. I basically used 10 times as much base as I did acid. So the next time I do this experiment, you see how I wrote undiluted? We need to dilute this acid. So we need to make this less concentrated. So if I make this less concentrated, I won't need to use as much base. So part A of this assessment, you guys are going to be given the base and the undiluted acid. You are going to not do a titration, but just a rough ratio check with pipettes to see how much how much base you need to add to neutralize the acid. And then from there, you're going to write a protocol explaining how to dilute this and by how much to dilute it by. So since this is about a 10 times ratio, what I would do logically is I would dilute this acid tenfold. So I'd make this 10 times less diluted. And if it was 10 times less diluted, if I did 10 mils from the pipette, I should then roughly get 10 mils from the base. And that's a more accurate, realistic use of my solutions. Does that make sense to everybody? Any questions so far? All right. So what I'm going to now do is show you guys the cleanup procedure. So like I said, this is a nice pale pink. You could maybe do a little bit paler, but I'll show you what overshot looks like so you know what overshot looks like. So I'm just going to basically put a lot more in there. So I know it's not very concentrated. So I might just actually empty it in there so you guys can see what pink looks like. And that's what you're basically not aiming for. All right, that's probably good enough. So that's what pink looks like. That's overshot. And I'll tell you that when you're doing it. All right, cool. So when it comes to cleanup, I'm just flushing everything out, just to get rid of everything. So what I want us to do is chuck everything down the sink because I don't want us to risk contaminating our stocks. That's why it's really important that you don't overfill these beakers because then you're just tossing away stuff that would have been fine. So I would rather you not fill the beakers too high so that way you just come up and get seconds instead of dumping a whole lot of solution that we don't need to dump. So I'm going to get these guys sorted. And luckily I have a sink nearby. So when it comes to cleanup, it's actually really, really simple. It's basically you take distilled water and everything needs to be rinsed with distilled water. So again, we're using the distilled water because I don't want to potentially have any of those little ions that then ruin my equipment. So with the flask, distilled water, do it a nice little flush around, dump it out, and you're good to go. Now I didn't rinse this initially because it doesn't really matter. If I did want to rinse it to start with, I'd be rinsing the flask with just water. It'd be fine. All right. Make sure everything is rinsed, so including the beakers that you use. Make sure you wipe the whiteboard marker or the permanent marker off. That's fine now. Just waiting for this to kind of clear out. So you see how I'm saying there's a lot of base that I've now wasted? So be more conservative. Just waiting for that to finish. Cool. Yeah, it's a lot to dump, but just to show you what not to do. All right, distill the water, rinse that out, wipe the whiteboard marker out so that way we can reuse it. Let's see. So with cleaning out the burette, again, distilled water, the easiest way to do it, I find, close the valve and you can put the distilled water up through the front. It doesn't need to be completely filled. It just needs to be decently filled. There we go. All right, the other thing we need to make sure we rinse is the pipette. Again, so final step, everything's getting rinsed with distilled water. I'm just putting some distilled water into a beaker. And my little doohickey. So in this case, again, do the same thing that you did initially when you rinsed it, overfill it, and then just chuck it out. In some of the pipettes that are a little larger, you're going to be able to actually put the little thing down it. So that's going to get rinsed out. You just need to rinse it once. And then you just return everything to where you found it. So I'm just waiting for that to rinse through. Don't forget the funnel. Rinse that guy out too. Everybody gets rinsed before it comes back to me. And that's why you guys have separate equipment for the titration. You don't use the normal lab equipment because we need to make sure the stuff stays clean. Because if we're measuring concentration, we don't want anything that could potentially cause problems. All right. What you're going to learn with titration is that you're going to have to be really patient because it does take a while for it to kind of flush through. But I really want to make sure all the little knobs and holes are cleaned out. So that way the next person that uses it has a clean equipment. But still, even assuming the last person's cleaned it, still do the rinse cycle as a safety measure. Any questions so far? We good? Yeah, I'm unfortunate that this did take kind of the whole period to show you guys, but I need you guys to understand step by step what you're doing. You guys actually won't be doing the titration for a while because you need to do part A first. But I just wanted to show you guys what you're doing so you understood why you're doing certain techniques to help with that accuracy. And also why you need to dilute. So if I didn't dilute, I'm going to go through buckets. And also not have it as accurate. Alright, cool. That's that all done. Cool. So rinse off the waste. Again, distilled water. Make sure it's rinsed out. And then everything can come back to me when it's all laid out. The other thing to kind of keep in mind, I don't know, I need to check how we stack it. It's useful to have these guys upside down like that. And I think when you guys return it back to the container, you store them upside down so that way it drains. And also it makes sure that there's no liquid inside here. Cool, and that's everything with titration. So hopefully that kind of helps. Like I said, those accuracy improving techniques is stuff you need to write about if you want, I think even merit, but definitely for the excellence. And like I said, you have part A and you have part D. There's 4 parts of this assessment, and both part A and part D, you're talking about those techniques. So yeah, that's basically how you do titration. Cool. Questions, concerns, comments, anything on that sheet you want me to go over again? No, we're good? Okay, cool. I'll stop this recording once I find my mouse, and I'll tidy up, and you guys have a couple minutes before your next class.